go ahead today. So today what we are going to do is we are going further ahead in um, the concepts, initial stuffs in PySpark, basically Spark. We are going to understand what is RDDs, data frames, and all those things, and then we are going to do some aggregation functions. Aggregation functions are one of the important part that you will have to spend most of your transformations as a data engineer. So as a data engineer, as we already have discussed, your major job is to get some data, build some meaningful information out of that, and you need to give it to the end users for their querying purpose or making business decisions, or for data scientists to build their predictive models and all those stuff. So when you enhance when you want to enhance your data, one of the integral part of that is you need to do a lot of aggregations. You may need to find some of that, you may need to get you may need to find average of certain things, you may need to find standard deviation, quite a lot of things you need to do that. So we will look into some of the functions, aggregation functions in PySpark. We also look into some of the string functions, joining strings and all those things. So before start, let's start with something what we want to discuss. We already discussed as a theory previously, understanding the data sets and RDDs in Apache Spark. So what is resilient distributed data? So we discussed this in our session where we given an introduction to big data, Apache Spark, Hadoop and all, and we told that RDD is a important core feature of big data, basically Apache Spark. So what is basically RDD? That's what we are going to do. So RDD is a functional data structure, fundamental data structure of Apache Spark. Fundamental means this is the basic in Apache Spark. From where all the data frames and all those things are built from. So RDD stands for resilient. That means can recover from node failures. Node means we have discussed, right? Hope you remember the Spark architecture. So in Spark architecture, each task goes to each when it comes, the driver program gets all the task, then it send it to your drivers, sorry, the workers, to perform this task in the each node or task, as like each core or node we used to tell. And even if there is a failure, it is built in such a way that it can recover and reprocess the data and send it in the right manner. So it is fault tolerant. That means the any like expectation of any issues is actually zero. Sorry, I have a bad throat, fever, and all these things. If you people I'm not clear, please let me know. I'm trying to be clear, but I'm not sure about that. That's it. Then the second RDD's second D is about the distributed. So data is splitted across multiple nodes in the cluster. That is, once if you give a data of 10,000 rows, it may divide this data into 100 different rows and give each set of data to each node for processing. So let's go again to the Spark architecture. You write a program. Kaushik is writing a program. Kaushik writes a program and runs. So Spark context get created and the driver program gets this data, divides this data into 100 different tasks and give it to the workers to work it on. So each node will be getting one task. Once it is completed, it will be giving its completed task back to the driver. Once all the task is completed, the driver will be joining all this information, giving it back to the as a result. Kaushik, you are not seeing the screen, is it? So let me just cancel and reshare. Aditya, can you see the screen? Now can you see the screen?
Yeah.
Okay.
Yeah, now it's available.
Okay. So I'll just come again if it was not visible. Okay. So we are discussing about resilient distributed data. Resilient distributed data stands for resilient, which means there is, even if it's any node failures, the data can be recovered even after the processing. So distributed means the data, if you give 100 lines of data, it can be divided into as per our wish. That is something which is we will learn later, which is called as partitions. We can partition the data, and with the help of that we can distribute the data equally, or depending upon our code efficiency, we can distribute the data among the nodes and run that parallelly. And something which is third is data set represents a collection of data which is immutable, which is only readable. This 3 is the feature of RDD, which is one of the building block of Apache Spark. So in the architecture, if we see, once a program is run by someone, the program is the creates a Spark context. From there, driver collects all the informations and it understands what should be executed. So the for 100 lines of data, if you say that we have 10 different, the driver have divided into 10 different tasks, and it is given to the worker to perform the actions. Actions in the sense, it may be like perform some aggregations or load the data from somewhere. Let's take aggregations because we are supposed to do that today. So meanwhile, let me start the cluster and keep it ready. Oh, I think I need to start a new cluster. Anyway, where did we? Okay. So let's come back. So the task is given, and each worker node get the task from the driver, and task here the task is given to the node. One particular core is also called as node. So each this one you can consider as node. If something fails here while performing, you have 10 lines of data here. That data failed due to some process issues. That doesn't cause any issues to the data or when it is written later as a result. It will be reprocessed, and it will be given, the data which is given back will be completely fault tolerant. And the second feature is the distribution of data. Anyway, it got the data as a single chunk. From there, it divided into tasks and given to each and every node. And this type of data is an immutable, which means it is read only. Okay. So when it comes to RDDs, it need to be it is a fine-grained control on the data processing because of all these features. And when you are working, it is useful when it is working in unstructured and semi-structured data as an advantage over our traditional method of processing data. So these are the basic features of RDD. So let's see how we create an RDD now. So this is we have a dummy data here in the form of a list. We are creating a RDD with the help of Spark context, and we are going to display the data. So here what it is happening is the cluster is starting. The data is been loaded. Later we are converting that data, which is in the form of list to RDD. Then we are performing a lambda function on that available RDD, that we are just doubling each and every value. Later we are displaying the result. Please give some time until the cluster is been cluster is started. It's taking some time to start the cluster.
Started.
Yeah. So it's already running. Let's see. So let's go through this code. So first we given the numbers as 1, 2, 3, 4. Then we created a RDD out of that. This is the syntax: spark dot spark context dot parallelize, and you are passing this list here. Later on that RDD, you are running a lambda function where you are multiplying it by 2. So your result should be 2, 4, 6, and 8 and 10. So you are getting this result. Collect is one kind of action which helps you to convert a selected data RDD, or later we will see when we want to collect a particular data from a data frame, maybe one column. You need to just select that column, and we just perform collect operation. Then you can collect all this data in the form of a list. So we will have some such kind of requirements which is coming later when we are doing some kind of operation. So this is one of an action to get a list from a data. So RDD will just go again. As I said, RDD is a resilient distributed data, which is a core feature of like Spark, which is stands for resilient, for like it can recur from node failures. Distributed is it is the one of the Spark feature where it helps to split the data into different parts, that the driver can spread all this data across different nodes for faster performance, for faster processing. And dataset, it is kind of representing the collection of data that is immutable. So let's see what is a data set then. A data set, basically it is a type safe. Type safe in the sense, each column, right? If we have discussed during the initial sessions with SQL and all, there are different type of data types. So each column, one column if it's date, then the complete, you will like see my screen, right? Yeah. So if the complete column is like date, we'll be specifying that it is date itself. So similarly, if it's the string, we will already will be defining it to be the particular data type itself. So it is type safe, optimized in Spark to combine features of RDDs and data frames. Data frames are also similar. It is like very similar to the relational database, like when we see the data in MySQL and kind of thing. And when it comes to dataset, it is only available in Scala and Java. In Python, basically when you work with PySpark, you will work with data frames. Everything is similar. You have some kind of basic difference. That's what we are looking into. And dataset enforce type safety by specifically a schema of this data. That means it won't allow you to write any data from any other. Like if you already have a data, already have a specific type of data type mentioned for each and every columns. It won't allow you to add any other data other than the specified type of data type there. And it also supports SQL like operations. Like in case if you want to, like if you people are familiar with SQL, you will have a lot of other functions, right? Where you will have like functions, you will have some kind of concat function. So it also helps you to perform SQL like operations there. And when to use data set is majorly when you want type safety, as we already discussed. And when you're working with structured data, it required performance. Performance in the like when you start to learn advanced Spark and all, you can write the program in different manner to make it more efficient. That runs when a program runs with 5 minutes, there may be a method that helps you to run that in 2 methods. That may be in code change, maybe the machine which you are using, all the stuff. So that is what it is called as performance optimization. And data sets is most beneficial and mostly used only when you are using Scala or Java. So let's see how to create a data set. So this is a Scala code where you are creating basically you are creating a data set. So here you are creating a case class, person with the two inputs like name and age, and later you have to create a complete data set out of this. So So it performs in there where we are passing the sequence here. It just gets that and creates a data set, and it is display function. It is going to filter. It is going to find out which who are like out of this data, who all are adults. So we will work on this. We will understand how this filter is functioning. So you only have two data. So basically we are displaying the same data. Let's see who all are above the age of 30. So the filter should find where in the complete data set where age of a person is above 30. So you should be getting only one data. It should be Bob. So let's see that. So you are getting only one data. So let's add few more data and see. And let it be 15 and let it be 16. So let's go and just make it ulta less than 20. So you'll be getting the two new latest data which we have added, which is below 50. So okay, I think I know. Age less than. So you'll be getting 15 and 16 here. So give me a minute before I go to the next one. Problem. So then let's go to data frames. Data frames is the one which we are going to use in our PySpark programming basically. It's very similar to data sets itself. A data frame is a distributed collection of data organized in names, columns, very similar to our relational database, the normal SQL data we used to see. And data frames are optimized for performance. It is already optimized for performance, and it is mostly working using the Spark API. And it allows structured operations, structured data in all the languages like Java, Python, R, and Scala. And when we use on what situations when we use data frames? Basically, we need to use PySpark. You will be using data frames itself. When you are working with structured and semi-structured data, it helps us a lot for transformations and all those things. It helps you to write SQL-like queries, and it also helps you to increase the if the performance is our priority. It have certain things like Catalyst Optimizer, Tungsten Execution Engine, all those things which will help you to run the program more faster. And so that specifies the difference between the data frames and data sets. So let's create a data frame now. So we have a Python list here with the similar data. We are creating a data frame. The syntax is Spark. Most of these cases we will in Spark, when you run, you will have the syntax of Spark. Spark dot some cases create data frame. Somewhere if you want to run an SQL statement, you can just write. Okay, you have that here. So Spark dot SQL, and you just run the same SQL statement here. It will run as a SQL statement itself. So now we are creating a data frame. Then we are creating a temp view. So we are telling about temp view and all those things last few classes. Tomorrow we will see more into what is temp view, what is view, and what is actual table, what is the exact difference, and on what situations we are going to create these things. And you are creating a temp view. That means you will have a SQL table kind of stuff which will be physically not available in any location, but you can query that as a table, something like that, which will be there on a high level. What is a temp view? And we are going to store this result here, and the show is basically kind of display. We will see that. We will like printing of the data. So let's see. We are going to same filter condition where age is greater than 18. So let's see. So you have selected only name. So let's change something and let's see whether that is working properly here. And we will add some more things here, like we will add location, kind of Bangalore, Chennai. And same here, you have, once you pass the data, right, create data frame, you're passing the data, and you also pass the what each column name is. You need to pass that to create. So let's see if I run without that column name whether it is going to work or not. Didn't throw an error. What will happen that we need to see, right? So let's see. You to display this data in normally in outside Databricks you have only option of show, but in Databricks you have something called as display which will help you to display this in a, see it automatically adds a column name underscore 3 to that. And if you specify a location like comma location, or let's make it simple as city, if you run that you'll get the name of the column as city, and that's it. So let's see. Now what we'll see is we will just take name comma city, and let's order by age greater than, and let's see, let's take the where condition out. You have something called as order by. We all know that we have order by in um, SQL, same SQL function we are writing. Whether it is going to work here or not, that's what we are going to see. We are going to order by age, and let's make it descending. Let's see that. So let's see. Okay, I didn't take age, so for better clarification I think age should be there. So let's see. So it is in descending order. Highest 31 came, then 29 came. So this says that you can perform SQL functions with the help of Spark API. That means you can write an entire code in SQL and just put that into a Spark API, SQL API as a string, and you can run that. That will give you results. So now let's see the differences, common differences between all RDD, data frame, and dataset. So if you ask like RDD, yeah, it is immutable, all these three things. Fault tolerant, yes, all three are fault tolerant. That also we have discussed. Type safety, when it comes to data frame, it's not 100% on type safety. Schema means data types. Schema like that we will discuss all those things later, because these things are little advanced. We are not into that, so you people will not understand this stuff. So just take it as a high level idea on this. So basic differences on data structures, RDD, data frames, and data sets. So let's look into some Spark SQL features, data frames, and how you are going to how you are going to perform this SQL operations into your data frames. So what is like normal aggregations, you need to do average, sum, count, how you do this process. When it comes to string, how to concat two columns. Let's see how to find a substring out of that, extract certain information from the substring, how to lower the case. So we have many other functions like uppercase and all those things. These all functions are being performed similarly. So we will not need to look into all this stuff where you can practice yourself other things, but we will look into these kind of stuff. And we also have how to work with some of the date functions, like in some column when you process the data you need to add a current date to that, maybe a current time to that, all those things. So we will just check how it is working here. We may need to change the format in certain cases of the date what we get. For that we need to find this. Sometimes when you enhance the data, sometimes we'll have two columns with dates. So that may be a data of take Amazon you have ordered something. So Kavana have ordered something on 20th of October, and it was delivered on 25th of October. Now Amazon need to understand the efficiency of the delivery team. So they need to understand the difference between the actual order date and delivery date, whether the product was delivered fast. For that, so you can find the difference between the two dates, that is the actual delivery date from the order date. So some such type of things. So when it comes to business, there will be many different requirements for the business owners to understand. So we will need all these type of functions to extract and give them this proper informations. So for that, first we are creating a data frame as similar as previous. Then we are going to find the average age. Then we can find the total age. Then we can find the count, like how many datas are there. So let's come and do these things. Let's do only average. So we have a data set of same Alice, Bob, everything came again, and so let's change the name Alice 1 and Bob 1 again. So let's find the average age in this data. So let's perform that. So you have two methods to do this. Now we are collecting this information as a data. So Let's see what happens when it. So as we already discussed, no, collect will provide you the data in the form of um, a list. So let's take what happens. It's basically providing you in the form of a row list. Then if you further go and take the index 0, you'll go inside to one row. Again, when you go and check one more index inside, you'll get the actual value. This is how we normally collect when you have multiple rows. See, in case if you have only like so if you want to uh, perform a group by here, okay, so you have multiple methods to do this aggregations. So let's see another method to do aggregation. So df dot, you have something called as aggregation functions. So that is all these functions which we will performing. So there you can do the same thing, f of sum, and you can perform this age. So now we want this type of things. When we want to perform this on a data frame, no need to print, but we need to save this as a data or something like that. Again, let's add city here. We want to find the average age based on each city. So let it, how it is going to work, let's see. Let's take 3, let's make it Bangalore. Let's make it Pune. So we have the data now. So we have 6 people now available. Let's see, like, oh, yeah, and we need to find the average age of people in each city. So for that, how we can do is, there we need to perform a group by function. You have average from there. You can also perform alias, and put alias will help you in case if you want to provide a new name after some aggregations, you can perform this. So you can put from avg underscore age. Then you need to perform a group by on this. So I need to perform a group by. Group by on, we need to perform on name and city. So we will find the name and city. We will sorry, we need just need on city. So we will find the average age on each city. Let's see. So we won't print that. We will just display that average age because it will be a data frame now. So let display. Okay, somewhere we have some syntax issues. Let's see. Not here, somewhere. Okay, we have closed this here. We need to close this here instead. Okay, you have here. Okay.
Close bracket.
Opening bracket here.
Yeah, opening bracket.
So you find. Okay, I have performed some, I think so. Somewhere, yeah, I have performed some. So let's put average. So you have the average age per city. So whenever you need to perform and find information based on one particular column or one particular information, that's where you can use this clause of group by. Group by will help you to find on the basis of certain other matrices. See, if you want to add maybe one more column, what we can add. Let's add the profession. So let's have something like this. Let's see what happens if we add one more. So we need to add to the group by one more column where you have need to filter the data on that matrix also. We'll add that and let's see that what happens. Now you find the data city and further filter down into each professional category. So you will go the average age of a person in IT profession in Bangalore is 29, where the average age of a IT person in Pune is 35. Average age of a student, it's little too much, but it is 30 as per our data. Average age of a driver in Pune is 32. That's because we have very less data. Let's make it maybe more meaningful rather than this to get some information. Let's make it everything Bangalore. So we have so so in Bangalore, IT persons have an average age of 32, where bank people have 31, students have an average age of 22, and driver have an average age of 32. So similarly, you can run many other kind of like functions, like sum, average, median. So depends upon that user request. So when it goes, mostly it will be business people who want to make meaningful information out of the data. So they will ask, they'll give you requirement that we need data like this. So then we need to understand what all functions we should be using there. So similarly, we already checked actually how sum works accidentally, but we did. So let's see how sum works. Sum is something is just same thing. Instead of function average, you put sum here. So you'll get the sum of the ages. Similarly, what is collect? So count. Count is nothing but it helps you to get the number of data, like nines of data. Sometimes you need to understand. This time happens mostly with me when we need to validate the data quality and all, to find whether the source had how many data. When you have a source means when you load the data, how much data was there after transformation? Did I lose some kind of data? Some kind of examples. I need to know like how much data was there in my column, like complete data. So in that we can use a function called as count. Count. We are getting our data frame. Select will help you to select certain columns. Now I'm just selecting the number of columns, maybe name, and just run that. Somebody else join now. Aditya, join that.
No, sir. Just I rejoined.
Okay.
I have some network issues. So just now.
Oh, okay. So I'm displaying something else somewhere here. That's why it's showing there. Let's comment that too. So I have total 6 entries. Let's validate that. 1, 2, 3, 4, 5, 6. We have 6 columns of data. That's what this count operation is helping us to get. I think you may have gone through all these things, either if you know PySpark, maybe in PySpark, or maybe in SQL also. So you have any questions here? Okay. I'll take that as a no and I'll go to the next topic. Similarly, in string functions also we will have some kind of requirements. So the business owner comes and tell you like, see, my data have a first name and last name, but my requirement is I need the customer name in full names only. So there you have some functions called as concat, which will help you to join two columns, strings in 2 columns. So let's see how it works. So it is nothing very simple. So I'll just explain you this code. We are just loading the data. It's very simple, straightforward list. You won't be getting data anywhere in real world like this. You'll be loading tons of data, mostly from different locations in the form of different Parquet, Delta, CSV. CSV are not very rare. Normally people in big data, people use Parquet and Delta and all. And it depends upon the use cases. And now we are creating a data frame out of this. And before doing the operations, let's see how our data frame looks. So let's run df.show. Show just displays. So it just displays the data. You have first name and last name. That's it. So let's uncomment that. And now, what is with column? With column in PySpark or in Spark is nothing but a syntax which will help you to add a new column. That new column can be with the help of the existing 2 columns, or it will be with the help of any new aggregations. Maybe current date we will see later, current date how to add and all those things. So with column is something which will help you to create a new column. So df.with column, we are creating a new column called as full name. How we are creating? You have first name and last name. So first name to last name to concat, we are using concat function. So what is this lit in between? So lit is nothing but it is a function in PySpark which will help you to give constant values, a string or something. So if you want to give a minus here, the end user coming and telling in my data between the full first name and last name I need a hyphen. Let's see whether it is going to come. See, I am getting a data like this. This is my data which I am loading. Later I just loaded the data. As per the request from the end user, I added a hyphen between. Later this end user itself came and told me, no, I don't need a sound, like a bar between, I just need a space. I just changed that. We ran and we have a space in between the first name and last name. Similarly, there is something called as substring. Substring is a function which helps us to extract a certain amount of values. Like you just need the first 2 characters of particular column, or I just need the first 10 characters. This kind of requirement comes that will help, that can be solved with the help of substring. So let's see how it is going to work. So let's comment this one and let's run. Okay, let it be there because we are working on the same and we are adding that. So let's see how this works. So here what we are telling is in the new column first 3 get the first names, first to third characters. So what is happening is first names, first 3 characters. I need ALI and Bob, and I am getting Bob. Say if I just need 2 characters, if I provide this, I will only get the 2 characters. So substring is a function which helps you to extract certain small strings out of the bigger strings. Now let's see another function which is called as lowercase. So lowercase is something like which helps you to lower the current. So now if you see in the actual first name, sorry, last name is processed here. The Wonderland's W is a capital letter. And let's use this function. Very same as we explained. New column is created with the help of int with function, and we are doing that. Let's run this and let's see we are getting expected output or not. So the expected output is W should be lower, and we are getting the lower. Let's try one more function, upper. So everything should be capital. So everything went capital. Yeah, column name is misleading, but everything is made upper. Okay, so I'll just uncomment that. This will be confusing when other people are working offline. So that's it. Let's go to the next function, which is dates. These are also very same. Okay, current date. So these current date functions are, we need to work a lot on current dates. To like mostly when you load the data, we will have timestamp data to understand when we loaded data, and sometimes when we need to perform some kind of actions, we need to have current dates. So let's see how it is working. So we have so for some difference, we are running a SQL query in the Spark API. So you have a data frame here, and we are creating a data frame, data out of that. Now let's see. Now here, instead of using this data, we are just creating a data frame which have a single column with current date. Let's run this and see. So this function, this simple straightforward function of current date, will give you the current date as a new column. This is one of the date function we normally use. Now that is simple and straightforward, no need to discuss much on that. This is something which you need to do always. Format date. My date need hyphen in between, you have given slash. There will be a request, then we may need to change. So this kind of things how we handle. So now let's see what exactly in our data frame the format is. Okay. So let's comment this first and just display and see how our. So let's see here. So here I have a hyphen in between and it is a complete timestamp. I just need date, and with the help of I just need in this format month should come first, then date, year. Here it is year, month and date. Let's see whether it is going to work. I'll explain the code before that. So the code is creating a with column, new column. This column name is formatted date. Then the formatted date is performing a function called as date format, where it is taking this column date, from that timestamp. It is just extracting the date into this and converting into this format with hyphens in between. See, okay. So we had this in this format. Now in our new data we have in the form of hyphen, that is month, date and year. Now again someone come and they change the requirement again telling I need year first, month and date. Let's see whether it is going to work or not. See, the same thing. So here, okay, 1 minute. It should be capitals, sorry. So you can see it came in the actual date in a different format. So this kind of stuff you will need to do a lot of transformation doing your work. These are like straightforward. When you ingest the data, when you clean the data, this kind of things will be required. So date functions, we are running very close to the time, so let's finish this quickly. So this is something which is called as difference. So I have two columns now. Now I need to find the date. So here, what date difference is doing in our coders, we are going to find the date difference from the current date to this date, to the date which is available here. So we have 1st of Jan and 10th of Jan. So from current date, it should be around 10 months difference. So let's see what is the difference it is coming. So let's run this. So we have around 267 days of difference from the current date to this 2 days. And second one, 258. And if you want to find a difference like that, and you need another column called as current date, you can simply do this. You can add a with column. You can do in two methods. You can add a backslash and enter and put a dot, and you can use. I normally prefer in a different manner. I used to do this. And I'll put this inside a bracket, so that will run as a same code. Okay. So I will put this current date as a column name. Name you need to perform given first, and second we'll put that f dot current date, and I'll run the function. So I'll get the current date, and next column will give you the difference also. Let's see what happens. The current date is 24 of September 2024. I'll get the difference like this. Okay. So we have some more topics to be covered, but it won't have sufficient time today. So we'll have some data manipulation things to be covered after this. So these are the basic things which we have covered today. Like we have done some filtering initially, then we learned RDDs, data set and all those things. Then we done some aggregations, we did some string operations, and we did some kind of loading kind of things. So I'm sharing this notebook with you people. We have given some real world scenarios here. You can do some kind of activities assuming some kind of data on this kind of building scenario, some data. You have a lot of things like online. You can even take some data from Kaggle, or even you just ask ChatGPT to provide a set of data. It will give you a set of data and use that and do. Okay.